All right, we are on page 11 in your notes packet. If you'll go there real quick. I'm sorry, not page 11, page 10. And we're going to go over what I do think, and I hate to say, is probably the toughest part of this whole chapter are these set of notes. So we have already addressed some of these rules that you are seeing at the top. We have addressed properties of exponents, and we did share that if it's the same base, then you are able to add the exponent, and that same base actually just stays the same in the answer. And then we had the same rule for quotients, for dividing, that you need the same base, and that here you can subtract the exponents, but that same base is still in the answer. And then we talked about radicals, that if you want to multiply radicals, they need to have the same index number. And that same index number that's common in the original problem will stay in the answer, and that you'll actually just multiply this. And if you have the same index, then you can divide, but again, that same index just stays there. So whatever the same is the same in the start of the problem is the same in the end of the problem. So where we're going to address now are adding, subtracting. Some are different. So I've only put some, but the same rules apply. So when you want to add or subtract with exponents, not only do you need the same base, you actually need the same exponent. Really picky rules. And we've talked about these picky rules before. So for instance, we've been adding, subtracting fractions, and this is just a little side note, but that you can't add and subtract fractions until they have the same denominator. And once you get that same denominator, so this becomes 2/4, this becomes 3/4, that same denominator carries all the way through. Okay? Another thing that you would have added or subtracted is x. You can't take x and add it with 3x squared. They both either need to be x or they both need to be x squared. So if the problem turns into this, then whatever's the same, again, adding and subtracting these really picky rules, if this is the same, then that's what's going to continue to be the same in my answer, 8, and then x squared. And you know, there are other things that were really picky through adding, subtracting, but this is just two of them that we've kind of done recently. So with that, since I have the same base and the same exponent, that same base and same exponent will continue into the answer. And what I'll do is look to see how many of them I have. So here's just one, so I have a total of 2. And then the same thing happens with the radicals. You need to have the same radicand or base, and you need to have the same index. Once you have that same base and index, then that can just continue through into the answer, and you look and see how many you have. So if I have one here and one here, then I have 2 of them. Okay, so again, multiplying, dividing, not too picky of a rule. Something's got to be the same, but adding, subtracting, you have to have a lot to be the same. So the idea is that we've got some problems down here, and we're going to try to figure out how you get through the problems. So the first thing I'm going to do is kind of sort them into, if you notice, I have multiplying, and then I have adding and subtracting. So I want to first bring my attention to all the multiplying problems. Just kind of moving around, I see multiplication signs, just marking these first. And what I will keep in mind that when I'm multiplying, so we are actually only talking about this top row here, that I need to have the same base or I need to have the same index. So some of these problems you're going to see, if you look at the next page, are ready to go, and some of them aren't. So we're going to talk about that they're almost there, but you'll have to do a little bit of work. So we're going to address our easier problems first. We're going to take problems that we can multiply because they are ready to go. They have the same base or they have the same index. So just kind of going left to right. When I look at my first problem, this has the same index. They're both square roots. So I'm going to take that problem and I'm just going to put it in my first box. It doesn't really matter where I put it. In any of the boxes, I should say. So I'm going to write my problem here. And while I'm thinking about it real quick, I do have to point out there is a typo on one of these problems. Right here, I don't want that squared to be there. If you can scribble that out, that second one, again, this problem right here, even though we haven't done it yet. All right, so I'm back to radicals. My 3 rules. I have fractions to worry about in radicals, and I want anything perfect not under the radical. So first I'm just going to make this one big radical. I'm going to follow that quick rule that I can do, and I get 81 and x to the 6th. And now I am ready to deal with this problem. I'm going to take out all the perfect stuff. So I tried to make these problems a little bit easier. They are all square roots, and maybe you realize, oh, 81 does have a perfect square root. It is 9. I'm not making a factor tree. And x to the 6th can become x to the 3rd. So I didn't make the factor tree. I could have made the factor tree and gone about it, but square roots I think we're pretty good with. So that problem is done and ready to go. So the next problem I want to look at, done with this one, is over here. So when I look at this one, is there something that's the same? And I need to have the same base when multiplying with exponents, and I do, so this one's ready to go. So I'll just put 6 to the 1/3 times 6 to the 1/2, and again, whatever's the same will continue through, so it's going to be 6. I just have to remember to add the exponents, and that's the pickiness because I need the same denominator. So you can use your calculator, but this will just become 2 6 plus 3 6 once I get that common denominator, and 5 6, and that gets to be my exponent. So again, in the first problem we had the same index. They were both square roots, so that went through. And in the second problem, they had the same base, and that stayed the same all the way through. So let's take another problem, look at another problem that has multiplying. Okay, so this one, is there something that's the same? In radicals, I need the same index. Again, I do. They're both square roots, so I'm just going to rewrite that problem down here. And it's going to look really similar to the problem at the top. So first I'll just make it one radical, so 24 x to the 7th. 24 is not perfect, so I'll go ahead and just make that factor tree. You could go about this differently, but 4 and 6, 2 and 2, 2 and 3. So now I'll rewrite it as 2 to the 3rd times 3 and x to the 7th. And then again, I can make my perfect and my not perfect. So of my 2's, there's a little 2 here. 2 are perfect, 1's not. My 3 is not perfect, and of my x's, 6 are perfect and 1's not. So bringing everything out from my perfect, again, this part's my perfect right here, I can get 2 x to the 3rd, and inside that radical that's still stuck is 6x. All right, so these are all things that we've done before. We're just starting to like put a bunch of different problems and, seeing how those go. So this one's done. All right, when I look at the next problem, this is radicals. Radicals need the same index, and this does not have it. So we're going to save this problem for later. Okay, this is one that's not quite ready to go. Let's move on to this one. So again, with radicals, I need the same index, and these do not. One has a cubed root, and one has a square root. So I'm going to save this one for later because it's not ready to go. And I'll take a look at the last one. So this is ready to go because they're both cubed roots. So just kind of rounding that up, finishing all the ones that are ready to go. Oops. So I have, sorry, can't see the problem. So just rewriting it, I have the cubed root of negative 5x squared and the cubed root of 25x. I guess I did put a cubed root in there. So first I'm just going to clean that up, make that one cubed root. So that's negative 125 and x to the 3rd. And maybe you're getting better with your square roots and your cube roots. But as it turns out, negative 125, maybe you want to break it up into this. But if you want to make a factor tree for 125, first I'll break it into 25 and 5. 25 can be broken to 5 and 5, and now I'll rewrite it like this. So negative 1, 5 to the 3rd, x to the 3rd, and everything is perfect. Remember, negative 1 always has a perfect cubed root. It's negative 1, and then 5 will come out, and x will come out, and then I'll just clean it up to be negative 5x. All right, so there is that problem. So let's just finish up the multiplying problems. And there were 2 problems. Whoops, let me cross this one off. There were 2 problems that I was not able to do because they did not have the same index. So what I'm going to do is go to this page, the almost there part, and I'm just going to write those problems down. So the first problem, I think the easier one, will be this. It was the fact that we had the cubed root of 12 and the square root of 12. And then the next problem we're going to do is this one, that we have the square root of 8 and the cubed root of 2. So this is just throwing a challenge out to you guys. I want you to see that, it might not appear that we can do them, but we can actually do them. So a few notes up here that I've not gone over with you guys yet is, first, is the problem in its original form, you can do it. So all the problems that I've crossed out here, in the original form, we could do it. But the problems that have been boxed in, we can't do them in its original form. So you know what? We're going to change forms and see what happens, okay? So we've practiced this. I've gone from exponents to radicals and radicals to exponents. So I'm just going to rewrite this as 12 to the 1/3 power and 12 to the 1/2 power. And now I'm looking at this as an exponent problem. And when I have exponents, I need to have the same base, which I do. And so my same base can continue through to the answer. And then I'm just going to add 1/3 and 1/2, which I've already done. That's 2/6 and 3/6, and that becomes 5/6. So I didn't think I could do it, but actually, as it turns out, I could do that problem. All right, this last one is a super duper challenge. So I just want to show it to you guys. And I'm afraid to say that, no, this will not be on your quiz, but I do want you guys to see a problem like this. And some people are looking for challenges. So just bear with me and watch this problem. So right now, the way the problems are, to multiply radicals, I need the same index, and they don't have the same index. There's actually a little 2 here. So what I'm going to do instead is what I did on the other one. I'm just going to look at them as exponents. So this is 8 to the 1/2 power. And 2 to the 1/3 power. And so what I'm still noticing is, gosh, if I want this to be the problem, like before they had the same 12s, well, these aren't the same. So switching forms didn't really help me. So what I'm going to show you instead is a little trick. And some of you, again, this is a really tough problem. I'm going to rewrite these so that they have the exponents, common exponents. So I want to look at 1/2. I want to look at 1/3 and realize I could get a common denominator of 6. So I can do that by making this 3/6 and 2/6. I'm not actually adding them, but I just want you to see that this can become 8 to the 3/6 and 2 to the 5/6. All right, now what I'm going to do is go back and rewrite these as radicals. These are both going to be 6th root problems. So I will have the 6th root that takes care of this part, and then I'm going to have 8 cubed and 2 to the 5th. And now I can just turn on my calculator and 8 cubed, 2 to the 5th, multiply those together, and get this answer. So this was a really hard problem, and I want you guys to see it. Some of you, this will click. Some of you would have to see this many times, but I just wanted to show you this. So what would you expect on your test? You can definitely expect, on your quiz, any of these problems, okay? And then these were just some more challenges. This one is a contender to be on the quiz, but I would not put this one on the quiz.